ao senhor
We
Rony pela
thank
disponibilidade. E
Mr.
nós temos
Rony,
online aqui conosco também
and
nessa
we're
abertura o
online
superintendente de inovação de Minas
with
Gerais,
the
o senhor Pedro Emboava Vaz. Ele
superintendent,
teve um pequeno problema para se conectar conosco aqui, mas agora já está
but we have
online.
problems
E
with
agora também
connecting
tem a
him,
palavra
and
com você, senhor
so
Pedro.
now we're going to open for
Agradeço, senhoras e senhores,
Mr.
mais uma
Pedro
vez. Acho que
Emboava
agradecer
Vaz,
também
Superintendent
ao
of
professor Fabrício,
Technological
ao
Innovation
magnífico
of
reitor
Minas
Marcos
Gerais.
Davi, ao secretário
Thank you
Cláudio
for presenting
que muito
here.
nos honra com a presença
It's an
virtual de
honor to
todos
be
e acho que
here.
agradeço mais uma vez a parceria
And
de
also
toda
thank
hora,
you for the
em conjunto
partnership
com a Secretaria de Estado de
in
Desenvolvimento Econômico com o governo de Minas. E para
with
nós, acho
the
que é
Federal
um
University of Juiz de
prazer
Fora
e
and
é
the
uma honra
government
que
of
a
Minas
Universidade de Juiz de
Gerais.
Fora, tão
The city of
importante, não só para o
Juiz de Fora is
desenvolvimento
very
econômico, mas
important
para a formação de mentes brilhantes, de novas
for
tecnologias, ela está
bringing new
sediando
brilliant
e organizando,
minds
protagonizando
and
esse workshop, que a
protagonizing
gente
this
tenha a ciência da importância
science and
no
technology
final das contas, a gente, enquanto governo do Estado, enquanto secretaria, entende da importância da geração de emprego e renda, e a gente tem a certeza de que daqui
job
para
employment
frente,
is very important, and this is going to bring it.
Isso só vai poder ser feito e
This
precisará
only
ser
will be
feito
done
utilizando intensivamente a
utilizing
ciência, tecnologia e inovação.
100%
E acho que a gente
science and
acrescenta
technology,
outro
and
ponto aí
this
dentro, que é a sustentabilidade. Acho que toda essa pauta ESG que tem se tornado
this
tão
brings
relevante também.
so
Ciência,
much.
tecnologia e inovação, em conjunto com a sustentabilidade, vão ser pautas extremamente importantes para que a nossa economia ela possa
Our economy will be
developed,
and the state of Minas Gerais
will
will be strong, and the outcomes will be of most importance. Philippe Routier couldn't be here today, and as the Secretary of Civil Aviation has implemented, the certainty is that the state of Minas Gerais firms the compromise of implementing this new technology, and this year will bring 62 million of reais for the development of sustainable energy and attraction of besides that, we have the state of Minas Gerais was the first one to sign an agreement with a British company about sustainable energy, and we're working to bring new investments and for the new the Federal University of Juiz de Fora is the correct location for implementing this new era of sustainable energy in Minas Gerais. For we are a hub, and together with the as a state, we have close quarters of close proximity to São Paulo and Rio de Janeiro, so this is an attractive value for our logistics and means for bringing this project to life. We have been increasing the flight path. Basically, we have increasing the flight path between cargo and flights commercials with private companies and federal companies. Besides that, it's important to emphasize Minas Gerais has the first engine, has the only other engineer of Embraer besides Juiz de Fora is the main character on this project, and the people and the rector and the university will support for the Juiz de Fora is very important to bring new investments for the population and the state, and we always be very proud of this partnership. We understand that the economic development is extremely important for the state, and the science and technology together with sustainability will bring a new era for our development, not only for the people of Minas Gerais, as well as for the people of Brazil. We are open to support this new era and this new project that will Thank you very much. We thank you, Mr. Pedro, and now the magnificent rector of Federal University of Juiz de Fora, Marcos Vinícius Davi.
So I'd like to start complimenting the Secretary, Rony Glanzman, and say that I'm proud and satisfied with this partnership that we're establishing. And I'd like to hail for Renato Dutra, who's representing Mines and Energy Ministry here. I'd like to compliment Pedro and Boaba as well, representing the economic development in the state of Minas Gerais. And we'd like to intensely take part in this project to develop the economy and innovations here in Minas Gerais. I'd like to make a special consideration to Professor Fabrício and all the research team from UFJF, and also the researchers of the Federal University of Rio Grande do Norte and Federal University of Minas Gerais, that are working hard to make this project great. As the university rector, I'd like to say that I'm honored to coordinate this project, but we are fundamentally saying that this is not an isolated effort. UFJF has already been recognized for having great quality in the graduation process for its students, and this makes us really proud to see this quality of formation. And once I was stopped by a student's mother, and she was worried because her son had been approved in and they had to anticipate his graduation so he could work. So this shows that our graduation is really strong. This month, CAP's evaluation results have come out, and there's been a great leap in the results of our post-graduation programs that show that UFJF is in the right path in the area of research and quality of post-graduation. And to end this trajectory of success, we have to talk about the great efforts we are making in the area of innovation and technology. This shows that a project like this is not something isolated. It's coming with a group of projects of innovation. And yesterday we were having a seminar in this scene, evaluating the results of the area of innovation, and these are results that make us really proud. But specifically in this theme of sustainable fuels and the vinculation of these fuels with civil aviation, we have a lot of projects that already have been developing in the last years, showing a clear vocation of our institution in this area. UFJF was already strong in the energy theme, and we have capacity to be strong in this area of sustainable fuels as well. Now Professor Fabrício will be representing me, will be receiving British entrepreneurs that already have projects with us, with the possibility to the possibility of growth in the production of this fuel in our industrial park. We have partnerships with Embraer and FAPEMIG with a lot of success in this area. So there's already some effort of the institution in this area. So we are really proud to say that we have great success in graduation, in post-graduation, and also we can safely show some important results in the area of innovation and the productive sector. And we hope to have some social economic value for our institution with these projects. I end my speech with certainty of the success of this workshop, and I reinforce my compliments to everybody present here, to our partners that are really essential for this effort. Thank you all, and I hope you have a great workshop. Have a good day. So we thank Professor Marcos Davi, and we thank all the authorities present here in this opening of the workshop, and we'll pass to the first presentation today. We invited the Professor Amanda Goldin to start this presentation.
Parece que a professora Amanda está com um probleminha de conexão.
Bom dia.
Good morning.
Perfeito, professora. Bom dia.
Good morning to all. I thank for the invite to participate as moderator for this panel. We're going to begin the first panel with the presentation of he's already joined us in the room. All right. My friend Rogério Benevides is an aviation engineer. His profession at the Federal University of the Fluminense. He has 13 years of experience in aviation, as well as experience with working at the Department of Civil Aviation Department. Also worked as the controls of aerospace. And today is the director of ANAC. I am honored to receive you today here. Good morning to all. Is everybody listening to me? I believe the transmission is working well. Good morning to all. Good morning to one of the most enthusiasts of the project, Amanda. We always comment that when we have the first of biodiesel, we'd have a national encounter. I would like to congratulate the Federal University of Juiz de Fora. This is a long-coming project, and it's helping us to the Federal University of Juiz de Fora has helped us with a variety of projects, as well as the Macaúba project. Also acknowledge the magnificent rector, Mr. Ronnie of Civil Aviation Secretary. I'd like to acknowledge everybody that has made the opening panel. Dr. Renato of MME, which is a big partner of us. This theme is very important, and we have been trailing it for a long time. And the velocity of this project has been increased, and its message is very clear. And the path that we hope to achieve. Another aspect that I would like to acknowledge, and 2 weeks ago, we have the OAS Assembly, where we consolidate the net zero for 2050. Another we have also another path that all the states that all the states we're going to work together for the net zero of 2050. How this is started, this is very important. We talk about an industry that we don't have production today, but we talk about a word that is called previsibility. For all the time that I have been working together here, I have divided the theme in 4 chronological states. From 90 to 2000, we had the confirmation that aviation contributes for the climate change. In 1990 and 1995, the OAS worked in 2 ways. One was motor engine and the other was motor noise, with the reduction around the airports. But not a contribution that would really help the sustainability. By the end of the 90s, this conscientization was a fact. In the first slide, we have the confirmation that NDCs will work among the international traffic and will be inside the Paris Agreement, and the OASI inherit the responsibility to work this issue. This one is inside the Paris Agreement. And we have the theme of by this division, we have from 2000 to 2010, where we said, okay, we have a consolidated civil aviation space, and what do we need to do about it? We started with prospects, with volunteers, partnerships. Until 2010, where we concluded that all the states, the national civil engineer will only work together if we work with sustainability. And between 2010 and 2020, how we would do that? And then we created and between 2010 and 2020, we worked, was created the CORSIA with SAF and among others partnerships. We are in a period of implementation with CORSIA, and all society enters with demands for implementing this really fast. Initially, when we discussed this, the problem wasn't the most relevant, and today the community of aviation and civil aviation sees that this theme of the implementation of CORSIA, it is of most importance for the commercial, and today what we are passing through is the conscientization of In this slide, in this point, that I would like to acknowledge, in 2002, in this period of pandemic, we had a fast approach for the question. In 2002, we indicated zero growth in 2050. What I'd like to highlight is that, truthfully, this path is a path without turning back and without this is initiatives around the world, and they are polonizing around the world. But this already had its rhythm. What's happening with this fast conscious is that it's there is a growth in SAF offer very quickly, and we need to do something. If you compare Brazil in 2027, where we are going to start to buy credits, our time space to offer is starting to become really short. This historic line, it's become even more shorter, and our time demands that we do something about it. And inside this scenario, Renato has mentioned some points about work, future fuel, which I really think it was one of the most important initiatives and most structured and important that we had in a long time. Okay. We were able to map and understand, but now we need to and we need to pass through this phase of understanding and pass through a phase where we implement this new directory. Petrobras itself has new matrix of energy fuel. The compromise for the if it's not available, we need to buy credit. If it's available, we will utilize this credit. We need to study a model of business that will embrace this opportunity that will work here. This obligatory demand finances the structure of a new economic settling ground for the Brazil. I believe, basically, that we are in a point, in a curve, in this process of fomenting and implementing the biofuel in Brazil. It is the fuel of the future. We already have these instruments. We only need to consolidate this compromise. We have to analyze case to case, together to see which better business model will be better to our needs. Critt is a big airport that has a major fuel consumption, and we need to study its case that will viabilize we have to have the domain the main domain and I believe that this short space of time we will make this in a very efficient manner. But for now, we need to turn the game with projects, with practice. We'll turn this requirement of demand and the area operators are and the last aspect is that they have a national policy with Corsia, which will if we have a fuel that if we need a fuel that is cheap and that the market can sustain it, and if we don't, we need to study which better way to achieve this. Our domain, and we need to utilize it to foment and fit in all the requirements for the new era of sustainable fuel. And it's this word that I like to end my speech now. We gave 2 big steps. Without forgetting the Brazilian participation in the Net Zero 2050. This is a national conquest. Thank you for all, and we are open for new discussions at the end of these panels. Thank you, Amanda. Thank you all. We thank the explanation of this historic new path that we are achieving. We have a lot of works that have been done, but we also have a lot of work to be done in the country. Thank you so much for the information that you brought us. This came in small steps, and now we are taking big leaps. To continue our panel in the SAF, in the matrix of energy fuel, I'll bring the rest of the participants in. We now have, I'd like to call Daniel Bachani. Daniel is graduated in international relationship by the Foundation of Dom Cabral. He also works at international relations at Embraer. He also is a coordinator of national
da OAS e demais fóruns internacionais, em especial em negócios relacionados à proteção ambiental. Então, Daniel, seja bem-vindo. Peço licença para apresentar os demais, né? Apresentar o Vinícius da Costa André. E o Vinícius está aqui com a gente.
So Vinicius is here with us. I thank you for your presence.
É formado em engenharia mecânica.
He is graduated in mechanical engineering
Com foco em
with focus on the acoustic, on dynamics, and he's specialized in flexible engines and has focus on diagnostics and monitoring of machines.
turbinas aeronáuticas de análise espectral com auxílio de inteligência artificial. O Vinícius está trabalhando na GE,
Now he works at
ramo de aeronáutica da
in
General Electric.
the aeronautics field of General Electrica.
Bem-vindo aí, Vinícius.
So welcome, Vinicius.
E aproveito para apresentar logo
And now I'll
né,
present Marcos.
colega de trabalho,
He's a work colleague for a long time now.
formado em engenharia de automação de controle,
He's graduated in
do IMBA,
Control Automation Engineering,
mestrado em sistemas mecatrônicos pela
has MBA and master degree in mechatronics,
de cooperação técnica do CETEC em CTI, da Secretaria de Desenvolvimento Tecnológico e Inovação do Ministério de Ciência, Tecnologias e Inovação. Tem trabalhado em gestões
he's been working in public management
em temas de energias renováveis,
in the themes of renewable energy,
avançados de conversão de energia. E hoje, né,
and now,
desde 2003,
since 2003,
tem atuado em diversos projetos de energia.
has acted in loads of solar energy projects,
E coordenador de
and now
articulados setoriais e plantas pilotos do projeto
he runs the pilot plant projects
de combustíveis
of
alternativos sem impacto final.
sustainable aviation fuel.
A todos aí pela presença.
So I thank you all for the presence,
Agora eu vou
and now
comunicar a todos, né, que isso está sendo gravado e disponibilizado.
I'll communicate everybody that this is being recorded and it will be available for all,
Para suas palavras.
and I'll call Daniel to take the word now. Good morning. Thank you, Amanda. I'd like to thank the authorities present here and my panel colleagues. It's an honor to be here with you to discuss this theme today. I have a little presentation for you to help me speak. I'd like to bring Embraer vision and what we have done here, why this is important for us, and especially how do we see this theme in Brazil. Next slide, please. So I'll talk about these 3 points. Why is SAF important for business that build airships and not only for those that use them? I'll talk about everything that Embraer already does with fuels, and mostly what are our conclusions and next paths here in Brazil. So, why is SAF so important for Embraer, and why do we talk so much about it? We talk about this for a long time, but it has gained great importance in these last 2 years. In this period, we could join important compromises with reducing the carbon footprint, and we are already applying some metrics. we reduced the emission values of Embraer last year, and our roof of carbon emissions is already really tight. We are already using SAF in our operations since last year. Without SAF in the production flights, we will never be able to achieve this goal. Most part of our emissions come from these goals, and we have committed to reach zero carbon footprint until 2040. We have this commitment to reduce the emissions. And I'd like to congratulate ANAC for the commanding of this project. And it's a global commitment, but it's also a national commitment. And this is really focused on what Embraer does inside. So how do we reduce our own emissions? Most part of our emissions are not with the producers of the airships. So what do the air companies do? So how can we help them to reduce the carbon emission? So I'll show you what we have done in the aspect of technology, and also about public policies and scientific spreading to help this challenge so that SAF can be available in the world. We built the first airship fueled by SAF, the Ipanema EMB 202. It's a small-sized airship with agriculture purposes, but was enough to test these new technologies. The size allowed for these tests with SAFs, and we already used this airship to test new engines. And we've been testing new technologies for almost 20 years with our partners and clients. In 2011, we took part in the process of this new route of producing fuel with an airship we made. We also tried a mixture of ethanol, and we have developed with Unicamp the development of SAFs here in Brazil. We took part in studies in Europe using a mixture of 25% of camelin, and we tested biorefineries of soy oil and ethanol. We have a huge history of developing knowledge and technologies for the public debate and for the production of SAFs and implementing of them. I'd like to bring this excellent news. It's really recent. It was in June. We achieved the first flight using 100% SAF in the airships. The flight took off in Florida, United States, and it took 70 minutes. Was 140 passengers airship. we utilize only SAF, 100% SAF in this 70 minutes flight, using both engines at the same time. And what adaptations we could do to the airship so it could use efficiently SAF on both engines. We don't have to have an issue with this, so the airships can be used in its totality with SAF as its energy matrix. And the next goals for Embraer, we are already considering that the airship will be certified with 100% capacity to utilize SAF in the engines. You are seeing the new airship we are developing. It's a last generation airship, and it will be on the market with the capacity of utilizing 100% SAF in the engines. We have some other tests in the way, and today it was announced that we will start tests in executive flights. Now I'd like to take the main conclusions. How do we see the issue of developing SAF here in Brazil? What are the barriers we have to face? And these are some of the conclusions we made. There is demand for the product. We have to take a leap in production. In the world, we produced a little bit more than 100 million liters of SAF, and Embraer consumed a part of this fuel we were able to buy. But to achieve our goals, we don't have to buy SAF, we have to produce them. Most part of our operations is here in Brazil. So to reach our goals, we have to produce SAFs here in Brazil as well, mostly. So until 2050, we have to reach a production of at least 449 billion liters of SAF in the market. Last year we produced in the world 100 millions. So there is a huge gap we have to go through. We need previsibility to unlock the investment in this production. In our view, that's the only thing that we are missing. So we have to bring previsibility to the investors. And here are some statements we made. So how we can have a head start in this discussion and start to invest in this product. So the tributary pillar is the first one. I would like to bring two important informations. So this mechanism, book and claim, utilized in the United States and Europe, is really important so we can unlock this development. So it would be, the idea is to buy SAF in a region you don't operate in. So in example, if you don't have operation in the Northeast, you can buy the SAF from a company there, and the credit will be attributed to the buyer. With this, you stimulate the usage of SAF in regions it is not already available. So we made a comparison between aviation kerosene, fossil kerosene, and the alternative kerosene aviation and the mixtures. This comparison is very interesting, so that today to import SAF for Brazil, it's 18% more expensive to import SAF. We are making higher values on SAF than we are making in fossil kerosene, and we can reduce the taxes. Another important part is the investment, and we need investment to install new plants and refineries to bring help and comfort to investors, and we have to define a national plan for SAFs. We still don't know what will be the policy chosen to develop SAFs, but it's important to have one. It has to bring availability for the demand, and the investments are billionaire. No one can be able to invest in a new plant if they don't know what are the rules they are playing with. So this investment would be pointless. So to unlock this investment, we have to define a plan and make it more with more previsibility for the investors. Thank you all, and I'm sorry for extending my time. It's a pleasure to be with you. I thank you, Daniel, for your words and for information, and to punctuate this with a strong manner with the points we have to work with to make the production of SAF viable in Brazil. So now I'll give the word to the next, to Marcos, to Vinicius. I'll give the word to Vinicius. You have 10 minutes to talk. Okay. Good morning, everybody. Well, beforehand, I'm sorry if there is any noise because I'm in the middle of the workshop here. People are working here while I speak. And I'd like to thank the organization of the event, everybody from UFJF, and the authorities here present, the colleagues, and I'm happy to see familiar faces here in this, and I'm happy to be here taking part in this event. Well, I have a presentation, if you could show it. Thank you. So I'm representing a small part of the industry, that is GE Selma. We do the maintenance of aeronautic engines. So we are entering in this sustainable aviation fuel, not as professionals in the area, but as consumers. There is this demand, and also the workshops that there is also demand that the workshops that maintain the engines make adaptations to comport SAF in the area. And the focus of this discussion is to be able to get out of here with partnerships made and to let my contact available so we can make partnership with the academy and with producers. So I'd like to thank for the opportunity and the invitation. So I'll talk briefly about Selma. It's the electromechanic company that started as a family business in 1951 and started to make maintenance of small electrodomestic and started to make maintenance in piston and ignition engines here in Brazil. In 1965, in the time of the military dictatorship, we started with this strategic sector. We should make the maintenance of the FAB engines, and with the privatizations in the Collor period, in 91 we started the privatization programs, and in 96 the actions of GE, the actions were bought by GE, General Electrics, and today we do the maintenance and revision of airship engines, and we'll show a little bit about it next. So the company has its venue on the Petrópolis city in Rio de Janeiro, and we have two test facilities in Rio de Janeiro. It's behind the international airport of Galeão. It was the biggest test facility in Latin America, and with new advancements we had to make a new plant in Três Rios near Juiz de Fora, and now this is the biggest test facility in America Latina, Latin America. So Selma is an important company in Brazilian industry. We have more than 2,000 employees and contractors, and we make more than 500 shop visits per year. So briefly, where does the sustainable fuel enter in this production line? So we have a production flow to show our production. Just like it would be with a car, the airship engines also have to have maintenance. So when the engine cyclage expires, it comes to a process of maintenance, and when it arrives in Selma, it has a process of inspection, then disassembly, repair of everything that needs repair, and then we have the reassembly, and before we return the engine, we realize a test. This test is made in the proof bank. I'm in the test facility here in Rio, and to this day we utilize fossil fuels to to fuel the engines we test. And here's the demand for sustainable fuels, to alternative routes for fuel. These here are the countries that gave us certifications. We take engines from basically the 4 corners of the world, and we have a high demand, especially from EASA, to start using SAFs in our operations. So this is an abstract of the 3 pictures are the testing rooms where we test the engines. We make about 500 tests a year, and in each test we use about 10,000 liters of fuel, which means that in a year we use about 5 million liters of kerosene a year. So considering the main routes, that would be Rifa and Fischer-Tropsch, that use 50% of fossil and sustainable fuel. Obviously, we can't make this change in a day. So, showing some engines that we utilize and we make the maintenance. They can be industrial engines and under the pictures of the engines are the airships that use these engines. So, these are some examples, and I got authorization to present this slide showing all the engines, all the GE engines we can use since 2006. And since 2006, the tests have been made with sustainable fuel. And this one in red are the ones we operate with. So, to show what GE Selma is doing, we are aligned with the SAF usage politics, and we want to transition to use SAF in the operations of in the test cell sites. I'd like to thank the opportunity to talk with you and to present a little bit of Selma. Say we are open to partnerships. We already have some partnerships starting, and with the team of UFRN. I'd like to extend this partnership with UFJF. We already have partnership with UFRJ. So you can reach me. There's my number and my email, and we can work together. Thank you, everybody.
Thank you for your presentation. It's very good to know there's already been testings, and this barrier will become thinner and it will be overcome in these new opportunities. I'll pass the word now for Marcos, which is an old friend. It's a pleasure to have you here, Marcos. Good morning to all. Thank you for I would like thank for invite and say hello to all the participants in this presentation, as well as the rector of UFJF and René Glansman. I would also like to acknowledge Rogério Benevides, Daniel, and Vinicius André, which are my colleagues in this panel. And I'll talk briefly on this presentation about one of the routes which certificate up by the INTN, which are about fuels by the rock called Fischer Tropsch. I work in the Brazil-Germany cooperation. It's 100% represented by Germany company. It's a company it's a technical company project with 120 panels, 120 countries. One of the projects that GEISE has here in Brazil is the PROCIAR. It's inside the partnership between Brazil and Germany. By the Brazil, in Germany, we have the support by the aerial engineering, and in Brazil we have support with the and this is our project for fuels that are friendly to the environment with the Fischer Tropsch rock. It is interesting to observe how this subject has gained visibility with Corsia. It was it was baby steps, and today I'm honored to be invited by the Federal University of Juiz de Fora to be presenting here, as well as the National Aviation Fuel Secretary. We are discussing this project and will advance even more after this. The project has started in 2021, and we had an addend to be extended to 2023 and maybe 2024. The pandemic has limited our time effort, but now we understand that we can further this. The initial project has 5,700,000 euros. To simplify, the project is divided by 4 components. The pilot plant, which is capacitization and implementation of the components. And we have 1 and 2 of the capacitation and implementation of components. This is the project that we got to develop the team to better fit the demands that we have. Just to make a brief explanation, power to leak is basically to utilize renewable energy until we get to fuels. This is an illustration about how we can achieve this. We have different sources of renewable energy, and we can combine hydrogen and CO2, and in the end we can have different products since from fuels and other products. You can already achieve synthesization of petroleum. This is a small illustration about a proposition, which is to substitute the phase of extraction. And the idea is to make a combination between renewable energy and fossil fuels. Besides to propose and implement the SAF project, we also have a challenge, which is to initialize this chain with a disruptive proposition beyond of our planning. We have a decentralization energy, and the idea is to the conventional system and all the cycle of fuels. We are implementing some, but still has impact on the environment, and the proposition is to reduce by total this. The development of this project was made by mapping and have niches and opportunities that came as viable options, especially in the yellow area of the map. This map is from 2018. It covers from aerodrome, hydroplanes, and hydro courts. So we have this is a small illustration in how we could use CO2 with capturing the CO2 from the air, and this is not the only alternative with renewable energy. Then we synthesize with hydrocarbonates, and this on the right, it's a small plant, so we could have a small perspective on how we could achieve that. Here we have possible sources of CO2 until we get to CPL SAF. We have biogas, alcohol to jet, and which brings CO2 and impurities, glycerin as a possible source, which I'll bring in further ahead. The cement companies, which we can reduce, and also the paper and cellulose industry. This is a timeline which we began in 2017, which have been made various discussions and talks and identifying possible partners. And between 2019 and 2021, we had a dialogue with various possibilities about technical viability, international partnerships with foreign companies and Brazilian companies. And since the beginning of the pandemic, we haven't stopped our conversations, and we have been dialoguing with various sectors, including the Committee of Fuels of Future. We have been talking with entrepreneurs, and we believe that soon we'll have a production plant inside these technologies, initially with a small scale, but these are topics that we cannot open yet, but we have signed agreements with 3 big companies in Brazil, one in Rio Grande do Norte, and PPSAF with glycerin, and one with COE biogas, and PPL-SAF from biogas, and a third partnership with University of Goiás, and the first month the Critt synthesis, and then the PPL-SAF with bioresidue, industrial bioresidue. By now, this is what we have been doing. This is a path without coming back. Since 2017, the interest is only growing, and it's very gratifying to see these institutions of academic and commercial interested in this project, and we are very happy with the outcomes that we are achieving. We already have Corsia, now we have the net zero. Things are out there in Brazil because of its location and conditions, geographic conditions. It becomes a potential player, international potential player, and it can be starting internal projects and then becoming a possible external in the fuel energy sustainability. To finish my talk, we emphasize that renewable energy is possible. It is already showing how viable that is, and our proposition is a decentralized production to have new sources of energy fuels. Thank you, Marcos, for your punctuations, for the continuity of the project ProQR. We are in the right path. And it's very good to see the evolution of our work. I'm going to have to apologize. We are not going to be able to open for questions due to our time. We're going to collect all the questions on YouTube comments, and we'll answer it further ahead. But thank you so much for the information you brought us. And this live is going to be available later on YouTube. I'll pass the word to Professor Laís.
Laís, antes da gente iniciar o próximo painel, né, deixa eu agradecer aqui.
Before I begin the next panel, I'd like to thank the talks and the participation of all integrants. Also, thank you, Amanda, for the brilliant moderation. And also emphasize the use of SAF in this new, all the contributions and talks are contributing for this new future and this new partnership with SAF, with these new opportunities for the aerial sector. Also, public politics that will further our country into a new sustainable energy and fuel. As Amanda said, we are not going to open for questions, but all that have made the questions will be answered. I'd like to invite Amanda and pass the word to her, which will help us on moderating the new panel. Thank you, Amanda. Thank you, Alice, for the invite. Thank you so much, Fabrício and Adilson, the UFJF team, especially Nicholas, for the organizing this seminar, all the authorities that has been present here. I'd also like to remind you that we have the simultaneous translation in English and in Portuguese, and the links are available in chat. Now I have to announce the participants. I would like to invite
these are all participants. Hello, everybody. I hope you are fine.
The name of this panel is Cadeia.
Pelo André Deferi, que é executivo no setor de energia, biocombustíveis, óleo e gás, e atua como diretor de desenvolvimento de negócios para Honeywell UOP na América Latina, no que se refere aos negócios de soluções em tecnologias sustentáveis. Então, passo imediatamente a palavra.
I'll pass the word to André, which are anxious to see your contribution. Your sound is not working very well, André.
Não te ouço.
We can hear you.
Ainda não.
I believe you have to leave and enter again the chat. It usually works. Just a few more minutes.
Nós sabemos que o André precisa sair antes por conta de voo, por isso eu não vou passar ainda para o próximo palestrante.
André has to leave for a flight, so that's why we can't skip him now. So that's why we're trying to
Oi, André.
Oi.
Hello. Can you hear me now? I have to do by myself. I'm sorry for this inconvenience. I'd like to thank all the participants and the organization, which is about SAF, which is very important subject, not only in Brazil but in international level. And the National Secretariat of Aviation. Thank you for the invite. In this presentation, Honeywell is an American conglomerate which we have about 100,000 of collaborators. We are present in the most diverse industries around the world, with more than 10,000 plants. It is a company that has installation of aviation and technology in turbines and technology for buildings, technology of securities that will warehouses for like Walmart that will capacitate for more efficient in this unity of this unit here works with we work with industry that has the refinery of petrol works. We don't produce oil chemics, but we develop the technologies that are going to be used by these companies that will use this. It's a more than 100-year company. This is a disclaimer that the Honeywell needs to present that this material is a Honeywell material, that this is not a consult, but it's informative about what Honeywell does in the sector of aviation. We're talking about here a lot about what is necessary to achieve the reduction of CO2 about technologies of aerospace aircrafts. This does reduce the CO2 levels, but we need to take it further. And today, the only solution to achieve this goal, it is the interchange and and include the SAF on fossil fuel. 75% of this goal will be achieved with SAF. A number of area companies are going to be using this fuel, and this brings a necessity to increase the use of this fuel. We also talk about what we need to do in public politics and security and investment for new partners. Projects of this nature involves multiple millions of dollars and are very expensive, and they take long to be implemented, also as law and impact and taxes that need to be approached and known with all partners. The governments that are working with SAF are very ambitious. If you take into consideration that in 2019, SAF only represented 0.1%, and now we understand that this demand are much higher during the pandemic, and how to increase the use of SAF in the civil aviation. This also brings a great opportunity for the Latin America, because it can be generated with a number of prime materials like soy, animal fat, as well as reforestation, and this not only for biomass, but also with processed HEFA. With the private sector, there will be new SAF and advanced fuels. The governments need to consider and decide if Latin America will be an importer or exporter of SAF. We also discussed projects that has perspective in entering operation in a short time. We need to understand, for the production of SAF, we are talking about processes that are complexes, are projects that are similar to oil refinery in equipment and operation. When you think about a new plant, after all the studies are concluded, it is a plant that needs 5 years to be implemented. If you already have a refinery that already has this kind of technology, we can reduce this time, but the average time is between 3 and 7 years for the implementation of SAF, not only for the complexity, but also for the how long we need. We have various that adds risk to the investment. Governments like Brazil and Colombia are analyzing how to produce this fuel. However, this process is very polar with the global scenery. These fuels attend and they are overcome the fossil energy of fossil fuel. We developed a process called, which is a partnership between with the project with the Secretariat, with the Department of Defense of the United States, with the Honeywell, Security and Energy, in a good relationship with cost benefit. We work. We've done extensive tests with the area forces of United States. Some milestones that we have achieved in 2012, we have the first flight using SAF with the Gulfstream 550 jet. In 2012, Honeywell started a project called with a drawing specific for SAF, and the implementation was in 2016 to use continuously SAF in their aircrafts. In 2012, we had a first Atlantic September 2001, we had an agreement with United Airlines and Honeywell for the production of WSAF with agriculture biomass that will be used. And in December last year, we had the first flight using commercial flight with passengers. It's a new route of technology. This is a bit of our experience. It has 25 years of experience with plants that started in 2013 with renewable source of energy. And we're starting to increase the capacity by 20%. Some plants only produce the biorenewable diesel, but we also study about SAF exploitation. When you think about SAF, it exists these two processes with food stocks, with oil sources that can be converted with fatty acids for the production of SAF. It can be flexible. It can be drawn specifically for this, and there are some that offer low processing with SAF. It produces a bit of kerosene of SAF, but also has a renewable of CO2. It can be used with oil refineries to offer the prime. We also can use biomass, like forestry residues, as these food stocks you can work. It attends as a sustainable source. The cellulose material, it can be converted and it can be processed in UFJF refinery, as well as to be converted to jet fuel. When you think about technologies that are available for us now, we only think about is United States and Europe that has that reduce significantly this CO2 reductions. We already have food stocks that are not considered food stock, that renewable, like SAF with palm oil. What can be done to overcome these obstacles? Which are the technological advance that we could bring to SAF and has a larger impact in the reduction of CO2? And when you look at that, what's going to be the future? What we can imagine the future and the technologies that will produce SAF. There's a process of routes that will utilize natural resources that will fulfill the necessities of CO2 for fuel. And when we look at that, we cannot look only at prime sources like oils. We need to look to other. 2 weeks ago, we had a public announcement with ethanol to jet for partner that has like utilize the HEFA route. It allows producers of ethanols like corn and sugar can be transformed into jet fuel. Jet fuel can be reduced by 80% since the production until the utilization of this fuel. This demand of SAF is growing, and also it is challenged by the demand, which are economically viable, and depending on the studies done by the Department of Energy of the United States, the production of ethanol and the technology combined, the ethanol and jet fuel can result in negative emissions comparing with the fuel and fossil fuel. This brings this potential of SAF. This brings SAF with a prospect of negative carbon emission. In 2021, we have this partnership with United Airlines, with SAF being produced from cellulose. This is the first project of SAF in the global level, and we're working with technology that will bring an upgrade on the production. It will transform this material in a prime material with the CO2 that will convert the biomass with the fat with oils to utilize this chain of production of SAF. It's proved. And these routes that are present today are the routes that show the biggest opportunity and viability today. I thank you for the invite, and if you have any questions, I can
Muito
clarify.
obrigada, André.
Thank you,
Me
André.
informaram que você tem uma questão de voo, então,
They
se
inform
você
that you have a
precisar
flight to
sair,
catch,
então,
so
no
if
seu
you need
caso,
to
a gente
leave,
totalmente
we
compreende.
can
A gente pode
understand that,
encaminhar dúvidas adicionais também para você por
and
e-mail,
we can forward the
depois. Mas
doubts that
agradeço muito a sua
you can
apresentação, foi
answer
muito
them later.
interessante conhecer mais sobre o trabalho da Hanwha
Thank you
e
so much for
como
your
esse ponto
presentation. It's
pode
very interesting to
ajudar a
know the
desenvolver
work
o
of
SAF
Hanway and
de
the
forma geral.
development of SAF
Mais uma vez,
in a
obrigada.
general method. Yeah, I have to leave. I have a flight right now, and I'll run to the airport. Thank you so much. Thank you for the attention and the opportunity.
Mais uma vez,
Once more,
gostaria de avisar os
I'd
nossos
like
ouvintes que a próxima apresentação vai ser feita em inglês, então tem o link
the next presentation will be done in English, and we have a link in
So now
the
it's an
description
honor
that
to introduce you to Charlotte Lawler. She is the Renewable Aviation Commercial Manager at Nest. She has a BS Finance, BBA Global Energy Management, and her background is over 10 years of experience in management, consulting, and energy strategy. So the floor is yours. Charlotte, it's a pleasure to have you here.
Thank you very much for having me. Can you guys hear me?
Yes, perfect.
Great. So I do have some slides I will present, and I will try to be brief because I know we have a limited time today. So thank you for the introduction. I am the commercial manager for Neste in the Americas. I have been with the company for quite a while. I started my career here by helping to launch and implement the renewable diesel strategy in the Americas. And now I've been focusing on our SAF strategy or renewable aviation strategy for the Americas. Very specifically, I focus on business development into Latin America. So I'm very happy to be here today discussing the topic specifically. Maybe it would help if I started with a brief introduction on our aviation practice. So let me make sure. Sorry, I'm having some trouble here presenting. It's not letting me. Here we go. Are you guys okay? Are you able to see my screen?
Yes.
Okay. So Neste's mission is really just to continue to be a leader and innovator in renewable fuels in general. We of course have been a very big global player in the renewable diesel space, but we are excited to continue innovating. And renewable aviation or SAF is our next big baby. In addition to transportation fuels, we also have renewable polymers and chemicals, and a variety of different kind of feedstock driven practices. Really, the aviation industry has committed to achieving net zero emissions by 2050. Aviation accounts for about 2, maybe 3% of the total global emissions, and it is expected to continue growing year on year. So really, our mission behind SAF and sustainable aviation fuel is to help bring down that number, and it's one of the key elements in driving those goals. I don't think it's the singular solution. Ultimately, to reach that goal by 2050, it's going to require sustainable aviation fuel, potentially electrification, and different types of technologies. So it really is an ecosystem that's going to require contribution and commitment from everybody involved, both users and producers. And the last point here is that despite the pandemic, the outlook on SAF is increasingly clear. I think the last couple of years have really shown us that now more than ever, we need to make a commitment towards addressing the climate change. So who is Neste? So we are the number one producer in sustainable aviation fuel and renewable diesel made from waste and residue raw materials. Last year, we helped our customers reduce over 10 million tons of greenhouse gas emissions. And today we are working with most of the major airlines in North America. Our customers include United, Delta, Air Canada, Alaska, UPS, FedEx, DHL, etc. We're also really excited to announce some partnerships we're starting to announce partnerships with customers in Latin America. Next week, actually, we will have a few test flights with Aeromexico we're really excited about. And we continue to kind of work our way towards the Latin American continent and customers. So what is SAF? This is maybe more for the generic audience here rather than my fellow panelists. It's really the next generation of synthetic jet fuel. Depending on the feedstock and process used, it can help reduce up to 80% of the greenhouse gas emissions relative to a fossil jet fuel. Our SAF is made from 100% sustainably sourced waste and residue raw material. It just burns cleaner in existing jet engines. It's a drop-in fuel. It's a great solution. And it is compatible with all of the current airport infrastructures and aircrafts, which is a really big advantage, let's say, for immediate adoption and implementation. So growing very rapidly, of course, the demand for SAF globally is increasing exponentially. We started our journey through innovation and production many years ago, but in 2019 was the first year that we truly started commercializing. At the time, it was about 30 million gallons of SAF that we introduced into the market. By next year, we will have over 500 million gallons of SAF production. And then within a few years after that, the 2.2 million tons is about 750 million gallons. In addition to that, we are continuing to innovate both on the feedstock side and on the production side. So there's a big move from Neste to increase our production on a global scale. So you'll continue to see SAF play a bigger and bigger role in our overall production pool. All of that being said, of course, feedstock continues to be a big challenge in the biofuel space in general. We currently produce the majority of our SAF through the use of used cooking oil and animal fats as a feedstock, depending on the production facility and market. In the near future, we are going to start introducing lignocellulosic and municipal solid waste feedstocks. So the lignocellulosic is the woody raw materials through paper mills and other wood processing facilities. And then we're also still looking at new technologies. Algae continues to be something that we're excited about, and Power to X is something that you'll start to see in the near future for Neste and I think a lot of the producers. And thank you. So a very quick and brief intro into Neste and SAF. And Liza, I know you mentioned that you had a couple of questions.
Yes, we do have a couple of questions. So we'd like to ask you, what were the main challenges of introducing Neste biofuels in the market of the United States? And what are your actions or expectations for the implementation of SAF in Latin America?
Good questions. Thank you. So I would say the main challenges introducing biofuels into the U.S., if we kind of look back about 10 years ago, there were maybe two types of challenges. So operational challenges, just introducing a biofuel into a logistics and downstream footprint that was designed for fossil fuels, of course, required planning and implementation, access, in some cases, physical segregation from either fossil fuels or other bioproducts is something that we just had to figure out, and really just entering the chain With that came then commercial objectives or commercial hurdles, educating buyers and regulators, right? What is a biofuel? What is renewable diesel? Is it safe? Is it safe for the people? Is it safe for the vehicle? Is it going to damage the engine? Is it better for the engine? All of those kind of questions were really prevalent, especially in the beginning. Getting OEM buy-ins, right, for a vehicle that's under warranty using a renewable diesel or a biofuel. It's always a challenge. And then differentiating from other types of fuels, whether that's fossil fuel or biofuels. But I would say the biggest challenge across the board when introducing any sort of biofuel is making the economics make sense. So having the markets and the regulators um, introduce different types of law or mandates that help incentivize the use of the fuel so that buyers can access it freely and regularly across their chain. Um, so what does that mean for, I guess, Latin America? It's a little bit different. I think the educational challenges aren't quite there because it's now been a decade. In general, globally, everybody's a lot more pro biofuel, and they're starting to really understand the benefit and the impact of the various offerings. The operational and logistical challenges are naturally still there. As you enter any new market, you have to be able to ensure access in the pipeline, in the logistics, and in our case for SAF at the airports, so that it is accessible to the various airlines and flyers. I think more importantly than the operational side of things is the regulatory maturity, right? So for Latin America, how do the various governments, because there's a lot of different territories, how do the various governments help to drive usage and incentivize the use of biofuels so that it can be accessible? Um, for SAF specifically, there's the geographical component of it. These airlines, regardless of where their originating flight is, are going to different countries. So ensuring that the regulatory landscape and the logistical landscape is similar in the various different countries in Latin America so that airlines can access it at all of the airports that they're trying to go to, and so that we can truly drive a total SAF usage as opposed to only the flights that depart from airports where it is available. And I think overall, it's the overarching challenge is the feedstock, right? So is there going to be enough access and availability of the existing feedstocks to continue producing more and more biofuels? And more SAF? I think the answer is no, which is why Neste and all of the producers in the space are looking at different technologies, different feedstocks, and different ways to both innovate, but also just to ensure access so that we can continue to grow the total share of SAF to fossil jet fuel.
Okay, thank you very much. It was very, very thoughtful to listen to you and your perspectives. So now we're gonna have our next guest, Mr. James Highgate. He's the founder and the CEO of Green Fuels, operating since 23. Green Fuels has supplied biofuels equipment to over 80 countries, saving over 6.5 million tons of CO2 emissions to date, and is currently establishing on-label biodiesel and advanced biofuels facilities in key global markets. Mr. Highgate, the floor is yours. Please, we are not hearing you.
Thank you for the
Now it's working.
working now. Great. Yeah, thank you for the kind introduction, Liz. And yeah, it's a pleasure to be. I'm actually in Brazil at the moment. First time I've been here since the pandemic, so it's great to be back talking from the FIDEPI offices at UFJF. So thank you so much for inviting me today. Yeah, as you mentioned, so Green Fuels has been around since 2003. We've been supplying decentralized biodiesel equipment all over 2008. And it was probably around sort of 2007 where we started to recognise that the future of liquid biofuels will move towards transport modalities such as aviation and marine. So we've been carrying out quite a lot of research into that areas. As a fuel supplier, we've supplied all sorts of specific projects, including we've supplied to King Charles for the past 15 years for his cars, which have been quite widely publicised. But looking at SAF, and I think the specific question I had was around international collaboration and why that's so important in this industry. I think a lot of that's already been covered today. As we know, the SAF industry is truly global, and actually the mandates and mechanisms and incentives vary globally, and I think it's very important that anyone in this space understands what's going on everywhere. So with things like book and claim, again, we need to know what's going on. It's crucial that this understanding is there. So we've actually worked here on a project funded through UK government with UFJF, and we've established a small-scale biorefinery here, which I'm looking forward to seeing this afternoon, which I've been to for a while, and looking at the decentralised production of a HEFA-derived fuel, for example, in this region. And I think the other thing to look at is actually there is no silver bullet for biofuels and biofuels production. Again, that's been touched on today. There are so many existing qualified routes for SAF production, and there's a lot of very interesting routes going through qualification or heading towards qualification at the moment. Feedstock being the key, and the availability of feedstock does vary wherever you are in the world. Certainly being here in Brazil, you can see the potential from alcohol to jet. You can see the potential for the HEFA-derived fuels. That might not actually be the case in Europe, where those feedstocks are less available. So for us, from the research side of the business, we've been looking at other biogenic waste and what could be utilised for SAF production, and specifically around sewage sludge. And actually, we see sewage sludge to jet as a very promising candidate synthetic fuel route, and we've developed a process known as Firefly. Again, part funded through UK government, but the plan is to actually move this through qualification, hopefully relatively quickly, and start the construction of a commercial facility in the UK in the next few years. But again, this is obviously a route of production that's relevant everywhere, because wherever there's lots of people, there's lots of sewage. And so to provide a truly green fuel. And here we're using a process that currently isn't a qualified route called hydrothermal liquefaction. But it's one of the things that we've found is in many of these biogenic materials that are available, they're wet. And so you have to use a process that doesn't necessarily require you to dry that fuel. So we see that as a great potential. And again, we're working internationally on the development of that fuels, but specifically looking at the UK for the first facility, but looking elsewhere for that. And it's I think there's this ongoing sort of innovation and research activity that is going on globally, and it's great to have these partnerships with universities and with research centres across the world looking at sustainable aviation fuels. I think it's one of the few industries where people tend to be quite open about what they're talking about, because the reality is, if you look at the global demands for the fuel, there's a very slim chance of coming anywhere close to meeting those with existing technologies. And so people aren't necessarily competing, we're all working towards the same goal. And so it's actually a fantastic industry to work in from that effect. And that's one of the big drivers for us as Green Fuels, is we're a mission-driven business and focused on our carbon impact. And we feel that specifically through these innovations, we can have a globally relevant carbon impact.
Thank you very much. It was great. indeed is a question of multiple stakeholders, and we all have to work together to make it happen. We do have a question for our audience. Felipe Garcia asked, what is the technological pathway to produce SAF from municipality solid waste? What is the expected difference in capex when compared to HEFA from soybean? So if you please would share your thoughts about that.
Okay, is there anyone specifically that question's for, or
If you please could answer this question, Mr. Hagen.
Yeah, sure. So municipal solid waste is typically a parcels gasification process, then through a Fischer-Tropsch process to convert that gas into a fuel. Very high capex because it's if you can imagine, municipal solid waste is different every single day, and so you've actually got to get a fairly generic material to a point where you can produce a suitable syngas for a Fischer-Tropsch process. But certainly, it's a very there's a number of plants in construction now across the world which hopefully going to develop this as a very viable route for SAF production. I think HEFA is here. It's now, as we've heard from Neste, this is the largest production of sustainable fuels available. It's it's effectively a refining process that's known, so the capex would be low, or would certainly be using existing and very high, proven technologies. And then you've got routes that we're looking at which are new and innovative, but actually, capex wise similar, so probably sits between the two. And with ours, we're using a process called hydrothermal liquefaction to produce a bio-oil and a biochar. One of the key things for us understanding globally what the uses can be, there's a number of co-products with this production, and we need to make sure there's markets for those along with the SAF. So if you actually look at the balance of technologies, there's each one has its own challenges, but they all need to work.
Thank you very much. We're going to move to our final panelist, and I'm gonna come back to Portuguese. Então, tenho aonde apresentar agora o senhor Marcelo Vidral, que fez engenharia química, tem doutorado em engenharia química também pela UFRJ, consultor sênior do Departamento de Hidrorefinamento e Processos Físicos do CENPES. Trabalha na Petrobras há 22 anos, sempre no Centro de Desenvolvimento e Inovação em Pesquisa. Então, por favor, senhor Marcelo.
Olá, bom dia.
Hello, good morning. I'd like to thank you all, to thank UFJF for the invitation, for the organization committee. And I'd like to comment that being the last one has a good and a bad side. The good side is that most of the things I would say has already been talked about. And the bad side is that I'm in a more challenging position. This was one of the reasons I didn't make any slides. And I had some lines to follow here, but it gives me more space to make comments and talk a little bit more about the reactional part of the routes. It's a part that I'm more keen on. To start, we're talking about SAF. Another event that shows the possibility and importance of the participation of academy for society. And this theme is very important for us because SAF appears in Petrobras in explicit form in this strategic plan that's coming to be realized. But it's explicit the way it shows there in the recognition of products and a formal positioning. In the actual planning, we are seeing investments in the order of $600 million in the production of renewable fuels. So we have a program called BioRefino. In this program, we want to refine in a sustainable way. We want to transition into a low carbon economy. So it was announced that we have this prediction to have the production of renewable diesel in the refineries, and this plant is a future vision we have to work with some initiatives in the bioprocessing and with high production of diesel with renewable content. But we strongly believe that for the future we need a plant with the capacity to refine more fuel for a year, and through this plant we can put ourselves in this transition to low carbon fuels and make our refinery in a better definitive way. So talking a little bit about SAF. SAF is not a one thing. There are lots of types of SAF, and it's interesting to say that some routes have already been talked about here for making SAF, and there's a norm that defines 7 routes for SAF production, for the production of SPK. So SAF is connected to this reduction in emissions. It can't only be synthetic, it has to be sustainable as well. So we have 7 routes with different raw materials and confection processes, and each route has some maximum percentages that fossil fuels can be added so it can be commercialized in the final product. These routes have this variation, and it's really important that SAFs have to be drop-in. They have to be compatible with an existing fuel. In talking about airships, production structures, and the rule to define aviation kerosene allows the co-processing of at maximum 5% of fossil fuel in the synthesis of the biofuel. Our unity uses the heifer route. But it's not just about technological maturity. It's the TRL scale, and we are working in the CRL scale. It's not about having all the steps technologically mature. So we choose this route for our unit. So why did we choose the heifer route? What is it? It's the conversion of three glycerides and fatty acids from a catalytic reaction in the presence of hydrogen, forming hydrocarbonates in a great array of products that you can choose from. So why the HEFA route? So we have a better technological maturity, and it's easy to integrate in conventional refineries. It has some attractability with material diversity as well. We can work with any type of oleaginous plants and cooking oil and some fatty acids. You can allow small and great volumes of production. On the other hand, we have some challenges of implementing HEFA. So it can be high cost, and depending on where you are, there are no great availability of raw materials. We already know that only the HEFA route is not enough for this process. And these oil plants have already been mentioned. The production of SAF actually happens alongside the production of HVO. And these are some challenges we have to overcome to use HEFA in the production of SAF. So there's also the question about sustainability, and there's a lot of pressure in Europe mainly. So we see this route as a preferential route for this production.
On the first step is the treatment of the feedstock. It's a fundamental step to guarantee the comfortability of the quality. This treatment is similar with the other steps of the production of biodiesel. For the HVO, you don't need the extraction of fatty acids. You don't need to use the residual. The cost of feedstock corresponds of the most cost of the project, and allowing to work with the after this step of pre-treatment, we have the step of hydroprocessing, which is covering the triglycerides.
And the fatty acids, and also to remove the oxygen that is contained in the molecule of the triacylglyceride. This remotion of the oxygen can be by two routes. One of them is the hydrodeoxygenation, that takes the oxygen out as water, and the second one is the DCO route, discarboxylation, that removes the oxygen in the form of CO and CO2. This generates paraffins and linear paraffins and propane. The propane comes from the glycerol when it unites the three lateral carbon chains from the triacylglyceride. Each of these two routes has different selectivities and different catalysts that allow favoring one route in front of the other. Today what is being looked for is more selective catalytics for the HVO water by remotion of water, because you don't lose the carbon and the side chain is not lost in the form of CO and CO2. This HVO route, if you look at the stoichiometry of this route, it will consume more hydrogen than the DCO route. Nevertheless, the generation of CO and CO2 in the DCO route, you're inside a reactor of HDT, you have hydrogen, you have other things, and they end up being hydrogenated, going to methane. And then you raise the consumption of hydrogen at the end of your cycle. So licensors of catalysts are working for finding more selective catalysts for this HVO reaction. Then you reach the first stage of the process. At the first stage you have paraffins of 15 to 18 carbon atoms depending on the feedstock, and this allows you to have a product with very good characteristics similar to diesel, with exception for the freezing point, the cold properties of this product, and because of the size of the side chain, you might have a difficulty to related to the flow of this fuel in Europe. So you might have to have more rigorous specifications for cold properties. So today we want to generate the SAF, and for that we need to adjust this product in the range of distillation of the SAF and the specifications of the cold properties. So what do we need? We need a posterior stage when other hydrogenation reactions happen, and you use a different catalyst system that will allow two kinds of reactions of HIDW, hydroisodeparaffинation. And what do these reactions do? They take a linear paraffin of 18 carbons, for example, from the first stage, and it ramifies this paraffin, keeping the 18 carbons but in a ramified chain, and then it keeps the energetic characteristics that it had before, but it reduces the cold properties of this material, and this would be the ideal component for the final composition of the SAF. Another kind of reaction that happens is that you need to get longer chains and break them in hydrocracking reactions. So if you want to have chains of around independent of the oleaginous type like soy that has more C18, but any type of oil, you have different distributions of carbon in the fatty acids, so you need to invariably break the chain to reach a lower carbon number, which would be between 8 and 16 carbons, mainly between 11 and 16 carbons. In the second stage we have two questions. Is that at the same time that you need to break and reduce the size of the chain, you also need to adjust the cold properties, and you want to maximize the yield. So you need to minimize the formation of light molecules. So at the end of the second stage, you have the formation of bio-GLP, bio-naphtha, biokerosene, which is the main interest, and the renewable diesel. So depending on what you want for your unit, you need to work in the compromise between the yield of the kerosene and the other products. And to do this, you need to work with catalyst selectivity and flexibility of the operational conditions. So this is critical for the process, so you can direct to the product you want, the biokerosene, and being flexible to produce at the same time the biokerosene and the HVO, and being able to adapt to different fluctuations in the market. At the end, you need a fractioning stage to separate these components and to put them to use. So related to the HEFA route, these are the comments. The aspects of the financial aspects here, I've talked more about the technological route, but not only for SAF but for any biofuel, the financial chain is complex and it's a puzzle that you have to fit the pieces, and if you don't have a perfect fit, you don't succeed in what you want. So you have challenges in all stages. Many of them have already been talked about along the other presentations. First is the feedstock, that you have to think about the availability, the logistics of the transport, the storage, the criteria of sustainability of this feedstock. If you're subject to seasonality or price fluctuation, also the quality and stability of the feedstock characteristics, and guarantee of supply. So related to feedstock, there is already all of these aspects to succeed in this entrepreneurship. So you also then have to choose which route is better for your case study. Each of them has their cost, and you might have to think about partnerships or finance or funding, and the market and regulation needs to be well known. You have to know well the legislation, not only of the country that you're producing, but the country that you're selling to if you're exporting. If there's a mandate, what kind of mandate is that? Is that related to volume, or is that related to reduction of emissions? If there is any incentive for which feedstocks, for which products, is there a penalty for these products, or there's a mechanism of production? So it's a very complex engine. And then you have the part of the product, that you have to adequate your product to the needs of your market, of your consumer, which market you're thinking about. In this case, it's the aerial sector, and the matter of the environmental question, that is one of the strongest ones for society right now. You have sustainability, relation feedstock and product. And an important question that we were commenting before is that the SAF is added in different percentage to the KAV. So you need to certify your product. You have to have a mechanism of certification to guarantee that at the end of your process you have sustainability and the range of renewables that you're delivering. You have to have a life cycle analysis to guarantee that your kerosene is effectively sustainable, it's not just synthetic. There's also the matter of competition, like fuel versus food, and the use of land that Andre has mentioned, that could make a penalty for some feedstocks. It's a complex, and it's not just a technological matter. And just to finish, it's not just technological, it's a big challenge to meet these goals of sustainability. And an important message is that we have space and need to incentivize all of the routes, the more mature and the less mature. All of them need to be looked at. There must not be any prioritization. All of them have to take into account everything that's been said, that the competition is not between the routes, it's a competition with the time. If we don't manage to overcome the technological and logistics challenges, we won't be able to reach there and meet the goals at the end of the decade. in the first goal, that is to take part in the course here. For all that, it is critical to have the legislation for the production of SAF to be defined and implemented as soon as possible, because the challenge is big and the time is short. And outside, other countries are far in the front of Brazil. So I thank you for the opportunity, trying to adequate to the stimulated time. And I thank for the opportunity, and it's open in case you have any questions.
Obrigada, Marcelo. Realmente foram bastante detalhistas, mas muito interessantes as suas exposições e escrever todo
Very
o
interesting your expositions.
foi essencial.
This process was
Temos
essential.
ouvinte assíduo aqui nas perguntas, né?
We have a listener that has sent us 3 questions, which are first he asks, is Paulo Montoya. He asks about the collection of residues and how can that collection can be, how these residues can be collected and how can they use. He also asks about the Petrobras challenges in a commercial level and the internal obviously some.
Então vou deixar mais uns minutinhos aí para você completar o seu raciocínio e as respostas ao Paulo. Obrigada.
And now we'll try to answer Paulo. I thank Paulo for the questions. I'll try to go step by step here. The first relation is the collection of feedstock, residual feedstock, and this is a fundamental point. It has been mentioned before that specifically to the HEFA route, the operational cost of a unit is very dependent of the feedstock cost. So if you can use more residual feedstock, it's more advantageous for you in terms of cost and environmental approach. In our case, Petrobras is a company with giant dimensions, so everything for us is big. To have a unit with a big proportion, there's not yet in Brazil a good system of collecting these feedstocks that has enough volume for us to guarantee that the production will be fully based in this sort of feedstock. Internally, we have some initiatives to try to fund these initiatives, and first we'd like to make it clear that there isn't a lot of this feedstock. If we manage to recycle all used cooking oil, even then that wouldn't be enough to fully operate a HEFA unit. We're far from that. So we need funding, because there is little availability, and whoever is first in this feedstock chain will be benefited at the front, because this is really important. What was the second point? So it's related to the route to commercial. I'm going to be brief because I can leave my contact at the disposal, but I came from the pilot plant. I've been in every stage of the development of the HEFA route until the development of the HBU, the renewable diesel from Petrobras, and we need to overcome a series of challenges. Just to have a notion, for this case, at the first time that we tried testing a pilot plant to hydrogenate soy oil, it wasn't even for SAF, it was for renewable diesel. It's a vegetable oil, and if you think about it, but we have some hydrotreated vegetable oil. The first time we produced butter instead of renewable diesel. So that was a big problem because we needed to clean all units from the pilot plant, which were really small, and it was all taken by a butter-like substance. And this is something that happens practically. We've done industrial tests. We've managed to approve the technology, but it's not easy to go from the laboratory to industrial scale. But a lot of stuff happens in this way, and you have to upgrade your route and manage to get more volumes to test the product, prove your concept, and to generate more data to characterize your product and guarantee that this has conditions to reach the specifications. And you have to generate the technical index, the stoichiometries, the yields, and for that you need to have a tool that guarantee the you have to have a tool for guaranteeing that the pilot plant goes from pilot to industrial scale, and you have results that are representative. And by the other side, you have to go to the industrial scale to test the concepts that can't be tested in pilot scale. You can see some features like feeding the plant that can be different. You don't have the pilot plant, so you can guarantee that you're fully developed. And which was the third point? The third point was related to the internal and external measures from Petrobras. So, technologically, it's already a viable route. There are plenty units of HEFA for SAF in the world. Not many for SAF, but it is a very viable route recognized by ASTM. It's commercially viable. You have commercial units, but apart from the commercial viability, it depends on you managing to put value in your product. So you come from a feedstock that is typically more valuable unless you manage to work with residues. You work with oils that might be expensive than the fossil feedstock, and you will generate a product that the market has to be able to pay for this additional cost. So the regulation must define very well if you're going to have some kind of credit, if you're going to be able to monetize the credits related to your product. So everything needs to walk, so we manage to be sustainable, and also sustainable for the environment and the financial side. So Petrobras has been mobilizing the spheres and taking part in the initiatives of the Fuel for the Future program in part of SAF and renewables. And we're waiting for these measurements to be published so they can direct us in a way to make this more sustainable. That's excellent, Marcelo. Thank you very much. Thank you all for all the great insights.
We are going to finish this panel, but I'm sure that there are a bunch of questions that the audience is sending for you, and we can share later. Obrigada mais uma vez, Fabrício, por nos convidar e por possibilitar essa troca desse painel aqui. Realmente muitas questões e provavelmente a equipe organizadora vai cuidar delas no momento posterior. Então, mais uma vez, muito obrigada. Eu passo a palavra ao Fabrício, desculpa.
Thank you, Laís. I would like to thank James Higgs. I would like to thank Ms. Charles Lola for your outstanding contributions. It's an honor for us to hold this workshop. And I would like to give a special thanks to Lais for moderating this panel. Thank you. And it's with a great satisfaction that we come to the end of this workshop with the certainty that we are on the right path to reduce CO2 emissions in aviation, and we make use of sustainable aviation fuels viable for us here in Brazil and for everyone around the world. And thank you for all participants. Gostaria de encerrar, então, né, fazendo agradecimento ao André De Faveri, que né, já está ausente, e agradecer a contribuição aí do Marcelo também. Muito obrigado, Marcelo. Né, mais uma vez, aí, agradecimento à participação da Laís. Né, a gente chega ao final desse workshop com a certeza de que estamos no caminho certo, né, para a redução de emissão de CO2 no nosso planeta, especialmente né, os relacionados à aviação. E mais do que isso, né, estamos construindo aí as bases sólidas para tornar o uso de SAF viável, sustentável, em todas as suas vertentes, tanto no nosso país quanto né, nas operações mundiais. Nesse encerramento, queria registrar né, a importância da parceria com a Secretaria de Aviação Civil, fazer um agradecimento especial à equipe da SAC, né, a todos os pesquisadores que estão envolvidos neste projeto. Né, a gente tem, ou a gente compartilha um grande desafio aí, né, que é trazer um estudo de viabilidade, um arcabouço técnico, um arcabouço de análises né, para subsidiar aí a construção de políticas públicas. Né, um agradecimento especial a todas as equipes que ajudaram na realização efetiva deste evento, a equipe do Critt, a Partex JF, a RBQAV, né, sem vocês a gente não teria construído aí, um evento né, com tanta qualidade. Né? Então, no geral, eu agradeço então, a participação de todos, nos colocamos então à disposição para futuras colaborações.
Thank you everybody, and we are available for future inquiries.